Hello, everyone, and welcome to Data Platform Virtual Summit 2021. My name is Amit Khandelwal. I'm a senior program manager with Microsoft working on SQL Server containers and SQL Server in Linux. Thank you so much for making time to attend this session today. And I hope by the end of this session, you are well acquainted with SQL Server containers that you can go back and start working with SQL Server containers in your environments. With that said, let's see what we have in today's session. So today, what we are going to discuss about is SQL Server containers and Kubernetes. So when I say Kubernetes, what I also mean is that we are going to talk about the different flavors of Kubernetes that SQL Server supports, as well as how you can deploy SQL Server on Kubernetes using tools like Helm in a way which can scale and work or automate the way you would want it to work on a production scale environment. With that said, I think it's time to go ahead and look at the agenda. The first thing that we are going to look at in the agenda is what is SQL Server containers. So we are going to spend, I think, briefly about 5 minutes or so just talking about the history of SQL Server containers, where are customers using SQL Server containers today, and how can you get started with SQL Server containers. So this is just going to be a brief brief topic in this session, but it's an important topic to set the foundations. After that, we are going to look at the most important core concepts, one of them being how you can go ahead and deploy SQL Server containers. Because if you look at the term that I'm using here, I'm not saying we are going to install SQL Server. Rather, I'm saying we are going to go ahead and deploy SQL Server. So when we talk about deployment, this is where we are going to talk about Helm, and this is where we are going to talk about Kubernetes platform. And after deploying SQL Server, what is the third option that you think we should be talking about? Yes, I read your mind right. We are going to talk about performance tuning for SQL Server containers, because whenever you run any software or any package in production, the most important thing to know about are the different knobs that you have to control SQL Server performance. And this is where we are going to spend some time to see what are the best practices, where are they documented, and how can you get started with those. So we are going to talk about that. Okay, so we've spoken about performance. What is the next thing that you would want to talk about? Yes, business continuity. And when we talk about business continuity for SQL Server or for any database product for that matter, one important part is high availability options. And that is exactly what we are going to talk about in this session. And after that, you've gone ahead, configured, you've tuned your SQL Server. Now you've also set up high availability. What is the other option that you would want to look at? Yes, you are right. We are then going to talk about how you can monitor SQL Server containers. So with that said, I think we have a lot of things to talk about in this short duration of time. And did I say that we are also going to do a lot of demos? So we have 50% demos and 50% slide content. So now let's get rolling and let's get started. Cool. So as I said, the first thing that I would want to start with is a small history of how SQL Server containers really started. I know I'm not going to go, a lot into depth in terms of when we started it, what did we do, what different achievements did we make, but I would like to talk about the milestones that we've kind of achieved in the last 2 years. So yes, you're right. So we started SQL Server in the year 2017 with the release of SQL Server 2017, and that was when we released SQL Server on Linux. And at that same point of time, we had the first SQL Server container image also created. At that point of time, SQL Server containers were only available for Ubuntu-based operating systems. But then in 2019, for the next 2 years, we worked hard and we enhanced SQL Server containers. So we not only enhanced in terms of features, but what we also went ahead and did was create solutions based on SQL Server containers. One such solution is the big data cluster. So big data cluster is based out of SQL containers. Another new feature that we have created today is Azure Arc. As you might all be aware, Azure Arc for data services is now available in GA. And this is also another product that we've gone ahead and built upon SQL Server Containers. So we are definitely looking at a very bright roadmap for SQL Server Containers and how you can run your databases in containerized environments. Now, with that said, as you've seen, our focus has been constantly there on SQL Server Containers. We've matched a lot of features in terms of, when you want to go ahead and compare this with SQL Server on Windows, SQL Server on Linux, and SQL Server in containers, you would see more than 95% of feature parity. And whatever is now remaining is something that we are focusing on and we are covering. So you can be rest assured that in few more years that we are going to see, we are going to keep building upon this legacy that we've kind of gone ahead and created. Great. With the history in mind, and as you would, with all the relevant dates in mind, it's now time for us to talk about SQL Server Containers and where can you deploy. So what are the different deployment options? Remember, in 2017, this was just an Ubuntu-based image. So what is the situation today? So when you look at containers, SQL Server Containers, what are the different options that you can deploy? The first thing is you can definitely go ahead and deploy SQL Server Containers on bare metal hosts or VMs. So you can have a VM, a standalone VM, and on top of that, you can go ahead and run a SQL Server Docker container. You could go ahead and do that. What is the other option? You could definitely go ahead and run SQL Server Containers on Kubernetes, and this is a completely production supported environment. So you get full support for running production workload on SQL Server Containers on Kubernetes. One important point that I would like to talk about is when I say SQL Server Containers, I always specifically mean SQL Server on Linux containers. SQL Server on Windows container is currently not supported for running production environment. But if you want to go ahead and run dev tests, you want to run certain testing, certain development, you can go ahead and do that. There is a GitHub project which I'm going to add in the reference section that you can look at, and you can create your own images, custom images, and start working with that. But that again, SQL Server on Windows containers right now is not supported for production workload. But SQL Server on Linux containers is fully supported for production workload. Now, with that said, when you deploy this on Kubernetes, you have two options in Kubernetes. One could be a Kubernetes deployment on premises. The other could be a Kubernetes deployment on a cloud infrastructure. For example, you might want to go ahead and deploy SQL Server Containers on Azure Kubernetes service. So this is basically a managed Kubernetes cluster example. Or you might want to go ahead and deploy this on an Azure Red Hat OpenShift, which is also called as Arrow, which is another Kubernetes, opinionated Kubernetes cluster. You could go ahead and deploy that. Again, that's a managed service. Similarly, you could build your own custom Kubernetes cluster in cloud environment. You could, go ahead, create multiple VMs, and on those VMs, you could set up a Kubernetes cluster. And running SQL Server Containers on such a Kubernetes cluster is also supported. And the third option that you can go ahead is the Red Hat's OpenShift. So you can go ahead and set up OpenShift again on an on-premises environment, or you could go ahead and set it up in cloud infrastructure. Even on cloud, again, both managed as well as unmanaged or custom OpenShift deployments are completely supported. So as you can see, we have opened a lot of avenues where you can go ahead and deploy SQL Server Containers. So you don't have to make a choice in terms of, whether should I go with this or that. Rather, you could go with an and choice where you can go ahead and deploy SQL Server Containers in your choice of environment. So I just wanted to provide you the different deployment options that you kind of have. Great. Now, we have a lot of customers who have started running SQL Server on containers. And one question that you might have is, what is really, why are we even talking about containers and SQL Server? What are the benefits of running SQL Server on container environment? The first benefit is the benefit that you derive out of any container deployment, which is portability. I mean, it is always easier for you to go ahead and share your your software, your package, and be able to set this up and get started, get running with it anywhere without thinking about whether the other machine would have the dependencies are all installed or not. Because when you create a SQL Server container, all its dependencies, all its packages are put into one single image. And when you go ahead and deploy this image, it comes with all its dependencies and packages. So it becomes really, really easy and portable. The second most important benefit is you just don't have to do any installation. You deploy SQL Server here. So think of it, if I have to give you an analogy for this, think of it as though you are just extracting a folder and all the contents of that folder are now available to you. That's exactly what you do with SQL Server container. You are just going ahead and deploying it. So you don't run installation. So you have your SQL Server running in less than 5 seconds. Yes. So you can go ahead and start running your SQL Server instances in less than 5 seconds. So you have absolute no installation. Now, this is easy. You don't have to do any installation. So you might be thinking, is this secure? And let me tell you, this is definitely very secure. This is the same SQL Server engine that you would run on a Windows machine or a Linux machine, which means you can go ahead and use TDE. You can go ahead and use encrypted connections. You can go ahead and also run SQL Server containers as non-root containers. In fact, we've gone one step ahead and ensured that starting SQL 2019, all our containers run as non-root, which is a recommended practice, security practice to run SQL Server containers. In fact, to run any containers for that matter of fact. Now, this is secure as well. So the other question you might have is, what if you want to customize this? We completely support creating SQL containers from Docker files, which are customized Docker files. There are certain supported, boundaries, and if you follow those guidelines and within those boundaries, the SQL Server container deployments that you have, which are customized container deployments, is completely supported. The next part which I want to talk about is, whenever we talk about containers, we always think them to be a stateless deployment. We always think that this is more about running, and once the container stops and restart, it loses its state. You can run SQL Server as stateless as well as a stateful set. And when you run it as a stateful application, it stores all the data that you have. So it is your plain old SQL Server running on containers. So it can maintain state as well. Great. With that said, where have I seen customers using SQL Server containers? With all the experience that I have based on my interactions with so many end users and so many customers, I've been lucky to kind of understand how container deployments are happening. And the 4 buckets that I normally see the container deployments happening are when customers want to go ahead and utilize resources of their bare metal or VMs. They go ahead and want to go ahead and deploy multiple instances of SQL Server. That is where they use SQL Server on containers, especially in Linux ecosystem. So if you want to go ahead and have, let's say, a few reporting servers, and also you want to go ahead and have an OLTP server, so you can have 3 instances, set up an AG in between them, start moving some of the data there like you would do on a Windows cluster, and then you could start, route your read applications towards your secondary containers or secondary SQL Server instances, and OLTP applications on the write or the primary SQL Server instance. That's exactly where I've seen customers use this in Linux ecosystem, because on SQL Server and Linux, you could just have one instance. The second part where I've seen this is when you have, CI/CD pipelines, where you want to go ahead and continuously build and drop the databases or instances once the work is done. You want to be you want your databases to be part of your pipeline. That is when I've seen customers also using this the most. The third place that I've seen is in a lot of test and dev environments to test their applications for performing functional tests, performance tests on their SQL Server applications for any new changes that they do for their applications. That is another place where I've seen, because the installation, the configuration part of SQL Server containers makes it so easy that you can, within seconds, you can set up an environment, get up and running, and start doing all your application tests. The Fourth bucket, which I've seen a lot of deployments happening now, is on providing database as service for their internal customers or for their end customers. This is where I've seen. So before this, where for every customer they used to have a database allocated within an instance. Today, they find it very, very easy to actually go ahead and set up multiple containers on running on Kubernetes platform, where each instance is actually one container, and that one container is allocated to a specific user. So that way they're able to actually easily understand the resources consumption in terms of CPU, memory, how much resource consumption is happening, and kind of provide database as a service to their end customers, which makes configuration, deployment, deletion, everything easier, because all of this can be managed through Kubernetes and through SQL Server. So this is where I've seen a lot of production use case happening, where the database as a service is provided to their end customers. So with that said, it's now time for us to look at how you can deploy SQL Server and what are the different methods to deploy SQL Server. Now, I'm going to go ahead and quickly talk about something called as the different deployment options. Now, when I say these are different deployment options, this really depends where you're deploying SQL Server containers. For example, if you're deploying SQL Server container on standalone machines or on bare metal or on standalone VMs, where this is probably for test and dev, you don't want high availability, you don't want automatic management of the pods or the containers. You're just doing this for your test dev environment, which you configure, let's say, every night. You run some tests, and after that, in the morning, you just want to go ahead and delete it. You can use Docker or Podman. Again, Docker or Podman both are supported to deploy SQL Server containers. Now, similarly, let's say you want to go ahead and customize your deployment. So in a single pod, while you would want a SQL Server container, at the same point of time, you also want to deploy your own custom application. You want to go ahead and run those together in a single container. So you want to go ahead and create your custom SQL Server container. At that moment, you can go ahead and start using Docker files. We completely support that. In fact, I have a demo where I'm going to go ahead and create a Docker file. And from that, I'm going to create a custom image, upload that custom image to a container registry, and then share it with my team members so that they can go ahead and download that image and start deploying it. So you're going to see a demo of this custom container images. So that is where you would go ahead and use the Docker file. The next part, which is mostly used, and I've seen a lot of customers using it. And when I say customers, I mean pretty much all the big sectors. You can think of them as banking sectors. I have seen health sectors. I have seen financial sectors, and as well as energy sectors, where customers have started using SQL Server containers for their deployment, and all of their databases are now managed via Kubernetes and SQL Server together. So we are going to see a demo for Kubernetes, and we are going to see how you can use Helm charts to scale and automate these deployments. So in Kubernetes, you could go ahead and just deploy a single container using a specific deployment YAML, or you can go one step ahead and use something like an Helm chart, which can go ahead and deploy multiple containers which are defined or which are templatized in the form of your deployment YAMLs. So don't worry. I mean, you're going to see a demo for this as well. So this is coming. Now, before I show you the demos for how you can use Helm chart, it's really important for us to just take a quick look at what Helm charts are and how it basically works. And if I have to put it in simple words, think of Helm charts as the package manager for Kubernetes. So how easy it is to use a package manager in Linux to install your packages, that is the ease that Helm charts also bring to your Kubernetes environment, where you can go ahead and deploy SQL Server containers, maybe 5, maybe 10, maybe 3, depending upon the number of replicas that you want. You can go ahead and deploy all of them with a single command. So think of it. So let me put it this way. You can deploy 5 SQL Server instances. 5 is just an example. You can deploy 5 SQL Server instances just with one single command like Helm install, and then the chart name and then the location where you have your chart. So all of that is possible using Helm chart. Now, again, if you want to read more about it, how you can create your own charts, or if you want to get started with an Helm chart, I have a demo which has a reference to a GitHub project where you can go ahead and create both stateful sets as well as a normal deployment. So you have sample Helm charts available for you to get started. But if you are if you are the one who basically is already aware of Helm charts and can write their own, you can go ahead and write your own Helm charts as well to deploy SQL Server containers. Great. Now let's just go one step ahead. And before we get into the demos, I just want to give you a quick picture that when you want to go ahead and deploy SQL Server using Helm, what are the different steps that are involved? So when you want to use Helm to deploy SQL Server, the first thing is, of course, you need a Kubernetes cluster. So you can go ahead and deploy a Kubernetes cluster quickly through Azure. So you can go ahead and deploy something like an Azure Kubernetes service, or you can go ahead and deploy the Arrow. Now, what is Arrow? Arrow is Azure, Red Hat, OpenShift. So you can deploy both OpenShift cluster or a Kubernetes cluster and get started with it quickly. So now you have the Kubernetes cluster deployed, but this is in cloud. You need a client machine from where you can connect to this Kubernetes cluster, correct? And this client machine, let's say, could be a Windows client machine. My laptop from where I'm presenting this session today could be my client machine, which I'm going to use to interact with my Kubernetes cluster, which is running in the cloud. So what I would need, what are the tools I would need on this client machine? The first thing I would need on this client machine is Azure CLI to install something called as kubectl or kubectl, as also what they call it, which is basically used to connect and start working with your Kubernetes cluster. So it's basically the CLI of Kubernetes cluster. To install kubectl or kubectl, I need Azure CLI. So I first install Azure CLI on my Windows client. And then I go ahead and install Chocolatey, which is again a package manager. I know we've spoken about a lot of package managers. So this is also another package manager, which is required to install Helm on Windows. Yes, you can go ahead and run your Windows client, and you on that Windows client, Helm is supported. So using Chocolatey, you can go ahead and install Helm. So now you have Helm installed, you have kubectl installed on your Windows client machine. So now it's time for you to start deploying. Yes, it's as easy as this. You already have a sample GitHub, sample Helm chart available for you to get started. So you can just clone that Helm chart in your environment, and then you are all set to go ahead with your deployment. And what is the command that you basically need to do to run the SQL Server deployment? You can go ahead and set up a replica value where you can say that you want 5 SQL Server instances running on this Azure Kubernetes cluster. And to install 5 SQL Server instances, you have to run how many commands? Just this one single command. This one single command will go ahead and install 5 SQL Server instances, or let me correct myself, deploy 5 SQL Server containers or SQL Server pods on the Kubernetes cluster. So it is this easy to go ahead and do it. Do you want to go ahead and take a look at that? I do hear some yeses here. So let's go ahead and take a look at this. Now, before we go ahead and take a look at this, I quickly want to talk about the support policies for SQL Server containers. I'm not going to spend a lot of time. This is also documented in our support policy. But quickly, if I have to just in 30 seconds, if I have to talk to you about support policy, the first thing that I would want to let you know is you need to go ahead and run your SQL Server containers or create your SQL Server containers on the supported distributions of SQL Server, which are Ubuntu, then you have Red Hat, and then you have Slash. So these are the supported operating systems. So you have to go ahead and take a look at those and only go ahead and create those there. The second thing, you can customize your SQL Server containers, but the most important part that you need to remember is you should not be changing any directory locations, binaries, or licenses of those directories and binaries and licenses. So those are the two important things. Yes, you can definitely modify the database location, that's a supported modification, but I'm talking about the binary directories that you should not be modifying. Anyways, all of this is very well documented in our documentation, so I'm not going to spend a lot of time here. So let's go ahead, move forward. Now, before we go into the details of how you can get started with Helm and how you can do it, let me quickly clarify to you certain things that you can control. First thing, SQL Server containers, you can deploy them as stateful sets, which means every container will have its own storage. And when you stop and restart, almost all the settings are retained even after it is stopped and restarted, because they are stateful set deployments. If you want to go ahead and deploy it normally, you could do that as well. So both the kind of workloads are supported. Second, when you are specifying the SQL Server manifest files or the YAML files, or the deployment YAMLs as we call, you can definitely provide the resource limits. We recommend running SQL Server containers as with a quality of service. So quality of service is a concept of Kubernetes, which basically means the requested resources and the limits for those resources are the same, which means you get guaranteed resources allocated to your containers. And we recommend running SQL Server with a guaranteed quality of service. The reference article and more definitions about what quality of service is, how you can verify that, is available in the slide in the reference section. The second thing is you can also go ahead and have an MS SQL pre-config file created, which gets loaded to each of the containers, and you can store this MS SQL config file inside your Kubernetes deployments as well. And the third most important thing that I want to talk to you about is you can go ahead and create external services, load balancer services, or node ports, depending upon the type of Kubernetes cluster that you're deploying. So all of those options are supported. So if I have to show you how a sample config file looks like, here is an example of a sample config file. And if you can see here, you can clearly see that in this sample, I have specified my limits. So this container can only run with a memory capping of 32 GB and overall 16 CPUs. So this is the limit that I've specified. I've also specified what port the SQL Server is going to be listening, and these are the different volumes that will get mounted to the SQL Server container. So this is just an example of how you can go ahead and create the YAML file. Now we've spoken enough. I think it's time for us to now take a look at the demo of how you can put all of this together. So here is the first demo that I want to talk about, which will go ahead and create a custom container, upload it to an Azure Container Registry, and then from there, I'm going to download this on my Azure Kubernetes service and run SQL Server containers using Helm. So let's go to the demo. Right, let's get started with the demo. So this is going to be a fast-paced demo. So, but do not worry, because all the demo that I'm going to show you here are linked in the additional information section in the PPT ahead. So you can always go ahead and try this again on your own. So let's get started with the demo. The first part of the demo that I'm actually going to go ahead and start is to build a custom container image. And to build a custom container image, the first thing that's basically required is, of course, the Docker file. So let's go ahead and take a look at the Docker file. And this, I'll just quickly take you through this Docker file. So what I'm going to do is I'll start with the base OS image, which is less12 SP5, then add a package called as libcap, which is basically to enable certain set of features like taking dumps and all of that. And then I'm going to go ahead and install SQL Server and also going to install SQL Server tools. And once I do the installation, I need to go ahead and give the right set of permission to the MS SQL user and group, because that's the user and group which SQL Server uses to run the SQL Server service itself. So that's the default group and user. And then I just go ahead and add certain set of privileges using the setcap, which is again optional, not necessary. And then I go ahead and also add the MS SQL config file, where basically you can provide all the configurations for the SQL Server. So this way, I'm basically going ahead and exposing port 1433, enabling certain configurations in SQL Server, and then starting the SQL Server as a non-root, which is very, very important. And that's why you see user MSSQL here. So if I have to build this image, all I've got to do is docker build. This is the command I basically need to run. I'm not going to run this because it takes a few seconds or probably about a minute or so to download the image and then build the layers on top of each of these images. So to save time, what I've done is let's just clear this. I have already created the image, and you can see I in fact not only created the local image, but I also pushed this local image to my Azure Container Registry, and the steps to do that is pretty much similar to what you would do when you want to push a local image to Docker Hub, right? So you basically log in and then you go ahead and Docker push, you first tag it, and then you do a Docker push. So why did I push this to a container registry? Of course, so that I can go ahead and share it with my team members, and I could basically use it in AKS as well. So that's the reason why I went ahead and pushed it to the Azure Container Registry. So if you had to take a look at it, this is how it's going to look. So this is my Azure Container Registry. Inside the repo, I have this /SQL repo, and this is where the tag is available for me. So this way, I can basically use this on Helm. So this is a proper way of creating a supported package for SQL Server container image. Now let's go ahead and look at Helm and see how I can use this image, which I've just uploaded to the Azure container in Helm. So to do that, let's just clear everything. So let's just clear everything. I already have Helm installed on my machine. So all that is set. And now to do the installation, all I have to do is I run Helm install. And once I do this, so I just say install MSSQL is the name of my chart. And then I just go ahead and accept certain values or environment variables. And once I do that, this is going to go ahead and deploy the SQL Server. While the deployment is taking place, it's time for us to quickly take a look at the values.yaml file. So let me just open the values.yaml file for you here. And as you can see here, what I'm going to do is let me just zoom in. As you can see we are going to get 3 replicas. So using this Helm, what I'm basically going to do is install 3 different SQL Server instances, each instance using its own storage, which is a persistent storage. And then also each of these instances will be configured with an MSSQL config file that is also available. And I'm basically going ahead and using the image that I just uploaded or just I created on using the SLES image. So I'm just going to go ahead and do this. And as you can see, this is where I'm going to go ahead and create. So when I come back to the Helm and just clear this and just run your normal kubectl commands. And remember, I already have connected my AKS cluster to the Azure Container Registry, and integrating your Azure Container Registry with Azure Kubernetes services, just a 1-step command, which is AZ AKS update, the name of your cluster, the name of your resource group, and then you just give the name of your attach ACR and the name of your ACR. That's the set of commands. So you can see all the 3 containers are up and running. Now to be able to access these containers, what I really need is the services. So for each pod, I'm going ahead and creating the service. So within few seconds, you should see, oh, I don't want to delete. You should see the services getting created. Wonderful. So here's an IP address that I already have. So I can just copy this and your typical tool, I'm just going to disconnect, database engine, give the password, don't worry. So I'm just connecting to the SQL Server. And now what I'm going to do is I'm just going to say run this select at version. Let's just do a execute. And now when you look at the output here, you can see this is using my SLES image. Easy, isn't it? I was able to create a local image, share it across, run it on Helm, and was able to deploy 3 SQL Server instances in what, less than probably 5 minutes, and with just about 2 commands. One was Helm
install, and the other was kubectl create the services. And all of this created 3 SQL Server instances for me. So if I have to access the other 3, all I need to do is get their external IP addresses. So I can just use this and start accessing them. Great. So those were the 2 demos. The first one creating an image. The second one using that same image to basically go ahead and use it in Kubernetes environment. After looking at the demo for custom containers and Helm, it's now time to go ahead and look at the next topic, which is what are your different knobs that are available to tune SQL Server performance when running on SQL Server containers. Now, we have a complete article available here, which is provided in this link, which talks about the different settings that are recommended for SQL Server on Linux. Most of these settings are also valid for running SQL Server on containers. Now, these are some of the settings that you would set up on the host where the containers are being hosted. And these settings include CPU level settings, they include network settings, they also include some of the storage and the operating system settings. So those are some important settings. For example, for SQL Server, for a host which is going to run SQL Server containers, this is the sample tuned file that it should be running, which basically sets up CPU specific settings and the OS specific settings in a way which is most configurable and as well as required to run SQL Server workloads. The second important aspect is around the storage. Here are certain recommendations that you can go, for example, which talks about the sector size, which also talks about what should be the read ahead settings and all of that. Apart from that, one important aspect that remains same, like you would do for any SQL Server engine, is following the SQL Server best practices. Example, having SQL Server database, log files, TempDB files on different volumes, following TempDB best practices, ensuring the number of TempDB files that are created are according to the number of processes that you have. Similarly, having the right sizes created to avoid, auto growth during production hours, all those best practices that you have for SQL Server, they are still valid for SQL Server containers as well. One important aspect that you need to also ensure when you're running SQL Server containers is that if you have set limits in terms of memory and CPU, please be aware that you can, when you set up a memory limit of, let's say, 10 GB, by default, because this is Linux OS, 80% of 10 GB is what is given to the SQL Server. And if you want, you can change this default option using the Docker deployment options as well, so that whatever you have allocated to SQL Server containers is completely available. Similarly, if you have set CPU specific resource limits, then you need to also ensure that you set up the right right values for parameters like max stop, which are affected by the number of CPUs that SQL Server can see. So you need to ensure that max stop values are accordingly set to the limits that you are basically going ahead and setting up for SQL Server containers. All of this documentation is available in the hyperlink that is given in this slide, so you can go ahead and take a look at those. So SQL Server containers is definitely production ready. Now, with that comes the next important topic, which is about the business continuity with SQL Server containers. And here I'm going to be talking about high availability options. Now, if you're deploying SQL Server containers on Kubernetes, Kubernetes themselves have the high availability option that is available at pod level, correct? So for example, if you have a SQL Server running on a pod, which means this pod just has one SQL Server container, which is attached to a persistent volume. And let's say the pod goes down, automatically the Kubernetes provides you the HA where the pod is tried, is started back again on the same node. And if the node goes down, then it can also go ahead and start on the other node of Kubernetes cluster. Now, this is a pod level HA solution that's already available on the Kubernetes layer. But let's say that you do not want to depend on this, but rather want to go ahead and set up database level failover options. And you also want pod level failover options to be provided by Kubernetes, but database level, because you want the database to be online after a failover within seconds instead of waiting for the storage
storage to come online, and then the pod to come online, and then the database to come online. You want the databases to be available in seconds after a failover. And you depend upon something which is the always on availability group feature of SQL Server. That is also today supported for SQL Server containers. So we have a partner, DH2I, who have started supporting clusters on containers, and they have a their clustering technology, which is called DX Enterprise, which basically goes ahead and sets up the clustering on the containers. And they also have an possibility of having heterogeneous replicas, which basically means that you can have one cluster which has one SQL Server replica, which is running SQL Server on Windows, another one running SQL Server container, another one running SQL Server on Linux. And you can just fail over your databases between these three heterogeneous SQL Server deployments. So they kind of support that kind of scenarios as well. So if you want to go ahead and support availability groups for SQL Server containers with high availability options, not the read scale, but I'm talking about high availability options on Kubernetes, that can also be done using DX Enterprise clusters. Now, how would you do that? First, definitely you need a Kubernetes environment. Second, you go ahead and create a custom container image. The sample file is available in a documentation, which again is added as a reference to this slide. And then after you go ahead and create the custom container image, which deploys SQL Server and DH2I's DX Enterprise packages, then you go ahead and deploy the container on using these custom images. You deploy the SQL Server containers, which contains the DH2I packages as well. And once that is gone ahead and deployed, then you go ahead and configure the DX Enterprise cluster and deploy the availability group. Though this might sound a little complicated in terms of so many steps involved, but let me show you a demo. And in less than 10 minutes, I will have 3 SQL Server instances deployed with availability group configured with all of this on Azure Kubernetes cluster. So let's go ahead and look at this demo now.
All right, in this demo, what we're going to look at is how you can deploy always on availability group on top of SQL Server containers, which is running on a cluster. So all the 3 containers are part of a single cluster, and your always on availability group can provide you complete high availability and disaster recovery features that you're used to. Yes, this is a work in progress with one of our partners, and this is covered under India, of course, because this is still not public out there. And what we're going to do in this demo is we are going to deploy SQL Server containers on Kubernetes clusters. Again, I'm using Azure Kubernetes Service as my Kubernetes cluster. And then we are going to create a cluster amongst the 3 containers, which are basically 3 pods. And this technology is provided by the DH2I, and the software is called DX Enterprise. So the DX Enterprise provides the clustering feature for us, on top of which we can then deploy always on availability group like we do for any SQL Server in Linux. In this demo, I'm going to use all the 3 instances as deployed on containers, but you can also have heterogeneous environments where one can run on a container, the other can run on a VM, which is running RHEL or Ubuntu, or it could run on Windows. So you can set up a cluster on all 3 nodes as well. So with that said, what we're going to do here is I just want to show you that we have already created labeling of the node, where one node is labeled as primary and the other node is labeled as secondary, as you can see on your screen. Why we've done that is so that when we deploy the SQL Server containers on top of it, we can have one single instance running on a primary node and the 2 secondary instances running on this node, which is a different node. So this way, if there is a node failure, we can then move this container to the secondary node by changing the label. So why did we do this? This just provides us, more resources for the primary, because that's supposed to be running OLTP transactions and whatnot. So we expect primary to have more load than the secondary. Okay, with that said, what we have here now is a YAML file that I'm actually going to show you. This is the YAML that I'm going to deploy. Of course, this YAML can change. And as you can see, we are going to deploy both MS SQL as well as the DX enterprises. And what we are going to do is we are going to have two replicas of the secondary and one single replica of the primary. And when we need to do a failover, we need to, and if it's going to be a node level failover, we need to just ensure that that secondary instance that it's going to run on might be of a lesser resources that you're going to use for. Okay, with that said, let's go ahead and deploy the environment. So to do the deployment, what I'm going to call is I'm going to say kubectl apply, and let's just go to the history. Yeah, and let me run this. So this should create the resources for me. And if I just see all, you'll see there are going to be two deployments for the secondary and one deployment for the primary. We'll just wait for the deployments or the pods to come online. Shouldn't take much. And let's just give it a couple of seconds. Now what I'm going to do is I'm going to expose these pods. I'm going to expose 1433, which is going to be my SQL Server instance, so that I can connect to these pods. And then I'm also going to expose 7979 port, which is going to be used by the DX admin tool to be able to have a UI control to control this. So to do that, what I'm going to do is I'm just going to say kubectl, and then let me just apply, and we go to the correct YAML file, which is going to be service.yaml, and this should get deployed. So now we should see the services getting created. So we have the load balancer service, which has the port 1433 opened, as well as the port 7979 open for us. So with this, now we are ready to connect to each of the pod, and then install the DX Enterprise software. And once I do install of that, I also can run the commands to run create availability group and do this. So let's go ahead and do that now.
All right. So now what we have is we have 3 pods running, and now what we've got to do is on the primary SQL pod, we are going to run the following commands as shown here. The first command is basically to deactivate the license for the DX Enterprise. The second command is basically going ahead and creating a virtual host with the IP address and also the name of the pod on which we are creating it. Mostly we would do this on the primary, so I've given the name as the primary pod, after which we are going to go ahead and encrypt the password for SA. Now in this demo, I'm actually using an SA password because this is the account that is going to be used to set up AG, but in production environments, and by the time we put this out, we will have a normal user configured for it. So for the demo purpose, I'm just using SA at this point of time. And then here, the next set of command, what I'm actually doing is I'm actually going ahead and creating an availability group inside the T-SQL, inside the SQL Server, using the command that is shown here. As part of the parameters that I pass, I basically give the name of the pod, which is going to be the primary, then the name of the SQL Server instance, the username using which you're going to connect, the password, which is again hashed, and then the commit mode, if it's going to be synchronous or if it's going to be asynchronous, and the port on which, the endpoint port, basically the always on availability group endpoint port on which it's listening. With all of that provided, the next set of things, what I'm going to do is I'm going to create a one-time password. This password is not needed for the primary, but this password will be needed for the other secondaries to join the cluster. So when you're joining the cluster, you basically have to give this one-time password. And then the next set of command is basically to add the database to the virtual host and the AG we just created. And this test database is already created on my primary, and I've backed it up so that I can add it to the availability group. Once this is all done, from the availability group side, we are set. The primary is now ready, and we can now add the secondaries. But there is one more command that you kind of need to run on the primary, which is basically to set the secret. It's basically setting the password for the cluster itself.
And this is needed because when you want to monitor this, or when you want to do the failover through the UI, which is the DX admin, I'll need a password here that I need to pass. And this password is what I'm going to set using this command. So once this is done, the next set of commands that you basically need to run is only on the secondary pods. And you need to run these 3 commands on both the secondary pods. In my case, I have 2 secondaries, so I have to run it on 2 secondaries. If you have 3, you'll have to run it on 3 secondaries. So what I do, the first thing is, again, activate the license, after which I say DXCLI join cluster, and then I provide the OTP which I just generated. And you need to do this within the time frame for which that OTP is valid. So when you run this command, you'll basically be aware of until when this the OTP is valid for. So you just need to run within that time frame. And then you just go ahead and add this node or this secondary pod as the replica to the AG which has already been created. So you have to just run these 3 commands on all the secondaries. And remember, all these commands are something that you need to exec inside the pod. So you basically, run something like kubectl exec -it, the pod name, and probably you can open a bash command and then run all of these commands. So you need to run all of these inside or exec inside the pod. Once you do that and everything has gone right, you would see the availability group created. You would see the primary, you would see the secondaries added to it, you would see the database, and you'd see everything is in sync. And as you can see, all of this right now is not in read scale, but in a full HADR mode of availability group that you are aware of seeing on SQL Server on Windows or SQL Server on Linux. And again, here again, you can go ahead and set up the availability group in such a way that you can set up the read-write routing URL, which means you can connect to the secondary. And if you've given the database name of the database which is added to the availability group, it will redirect you to the primary, and you can run your insert update queries or the queries which intend to write into the database. So all of this is done. Now, all I showed you through this is all the bash way or the CLI way of doing it. You can do all of this through the UI as well. And I'm going to go ahead. The server name is basically the external IP address of any of the pod, because all the 3 pods expose the same 7979 port. So you can just use any of the external IP address and then provide the password, which is the same thing that you set up. And okay, let me just try the password again. I think I just mistyped something. Perfect. It's connected now. And as you can see, I have the availability group added here. Basically tells me which is the primary, which is the secondary. These are the 3 replicas that I have. If it's synchronous commit, if it's online. If I want to do a failover, I just click on one of them and just say start hosting on a member. This will immediately do the failover. And it also basically says this cluster is set up on all the 3 pods. So this way, I have a complete availability group set up.
Well, after looking at the demo for the availability groups for SQL Server containers, it's now time for us to look at the last part of this topic, of this discussion, the last topic for this discussion, which is monitoring SQL Server containers. Now, I had 2 sessions for this DPS event, and this is the same monitoring solution that I also presented for SQL Server on Linux, and the same monitoring solution can also be used for SQL Server containers. So if you've attended my first session, which spoke about monitoring, you should be able to use the same monitoring setup for SQL Server containers as well. And what is that setup? This is basically the setup using the TIG stack, which is the Telegraph, Influx, and Grafana. So using this, you can go ahead and set up a near real-time monitoring for SQL Server containers. In fact, you can make this entire setup appear on containers itself. So you can have Telegraph, Influx, and Grafana all on a single host with different containers. And then you can go ahead and start connecting to different SQL Server using the Telegraph plugins that are available here. And if you would want to go ahead and set this up yourself, I have a blog which I kind of authored that you can go ahead and refer to understand how you can set this environment up. And the good part is I also have a demo here, which is the same demo that I presented in the session for monitoring SQL Server in Linux, and the same demo is presented here as well for your reference. So if you have any questions in terms of how you can go ahead and use this monitoring solution, please do feel free to go ahead and reach out to me. With that, let's go and take a look at this demo.
It's now time for us to go ahead and take a look at how you can go ahead and set up near real-time monitoring for SQL Server running on Linux containers or even Windows using the Telegraph, Influx, and Grafana stack. Now, in this demo, what I'm going to do is I'm using this one single host, which is going to host all the 3 containers, and each of these containers is going to run each of the services that we are looking at. So we will be running Telegraph on one single container. We'll then run Influx on another one, and the third one is going to run Grafana. Now, because this is a demo, I am able to go ahead and run all the 3 containers on one single host. But depending upon the data that you're collecting and depending upon the resource utilization that's happening for Influx and for Telegraph, you might choose to actually go ahead and run each of these containers on different hosts, or you might just go ahead and run 2 containers on one single host and the third one probably another host. So that is something that you'll have to take a look at and decide depending upon the resource utilization that you see. Now, that said, what are we going to do in this demo? So as I said, we are first going to go ahead and run 3 containers, each container running Telegraph, then the other one running Influx, and the last one running Grafana. Now, for these 3 containers to be able to talk to each other, we are going to have these containers deployed in the same network. So to do that, what we'll first go ahead and do is we'll go ahead and first create the network. So to create the network, the command I'm going to use is this. Now, again, please note, I'm not going to go ahead and do the creation now because I've already gone ahead and created it to save some time. So as you can see, the driver that I'm using for the network creation is Bridge, and the network name is InfluxDB Telegraph and Net. So yeah, you probably think this is way too big a name for a network to go. But with that said, once I go ahead and create this, you can go ahead and take a look at the network that gets created. So you can just say Docker network ls, and you will see this new network that we created is listed here. So now with the network created, it's time for us to go ahead and start deploying the containers. Now, the first container that we are going to deploy is the Telegraph. So for that, what the command is going to look like is something as shown here. So we are going to say Docker. So the command is going to be Docker run -d name of the container, and then I'm also hosting the telegraph.configuration file, which is on my host machine. So this is a modified Telegraph configuration file, or should I say a customized Telegraph configuration file, because this configuration file has the information of my target SQL servers that I need to kind of go ahead and monitor, right? So this telegraph.configuration file is what I'm mounting to the container inside the HC Telegraph, where the configuration file is, and then the network that I just went ahead and created, and the name of the container that I'm actually going ahead and creating. So again, I'm not going to go run this, but in fact, this is already done. So let's go ahead and now take a look at the configuration file that I have. So I have gone ahead and opened the configuration file in a Notepad++ for us to take a look at. As you can see, this is a configuration file which is also available as in the GitHub project where this plugin is defined. So you can go ahead and take a look at that plugin, and the reference for that is also provided in the presentation or the slide deck that we have. Now, coming back to this configuration file, as you can see here, I have gone ahead and uncommented the database type. So I let the Telegraph plugin know that the database type it's going to connect is to SQL Server, and this is going to go ahead and by default collect the following data. As as you can see, this is the data it's going to go ahead and collect. So it's going to go ahead and collect the performance counters, the weight statistics, the database IO, the server properties, and other information all from DMV. Because this information is coming from DMVs, that is why this SQL Server basically, this plugin is basically going to work for SQL Server running on Windows or SQL Server on Linux or containers, because DMVs are present across all the SQL servers. Correct. So once we go ahead and ensure that we give the right database type to the plugin, it will be able to go ahead and connect to those SQL Server. Now, to connect to the SQL Server, it still needs the information like what is the server, what is the port, what is the user ID that I need to go ahead and connect to. And that is the information that we provide here. As you can see, I provide my server, which is the IP address and the port 5433. This is the user that I've already created on this target machine. And this is the password for that user. Of course, this is not the password. This is just a made up password, but you understand the whole idea. So you basically provide all your target servers. So I provide all my target servers, and on all those target servers I've already gone ahead and created this user and the password for it, and that way it'll be able to connect to these SQL servers and collect data. Now, on if you have to take a look at these SQL servers. Here are those SQL servers. So this is a SQL server which is running on Windows. This is a SQL server running on Windows. This is the Telegraph user that has been created. And as you can see, this Telegraph user that I've created, I've not given this a sysadmin permissions. In fact, this is just a normal Telegraph user that has been created without any sysadmin permissions. The only permission it has is the view server state and view server state information, and another one more permission that is just needed to view the DMVs, right? So only the information that is the permission that is required to view DMVs, that is only available with this user Telegraph. So once I go ahead and set my target servers and create those, the logins for them, I'm all set to start monitoring them. So the requirement to monitor any SQL server using this stack is that you need to go ahead and provide that information here, and you need to go ahead and create this user on the target SQL server. So once done, I can go back to my, let me go back here. So I can go back to my server where my Telegraph is running, and this configuration file is already uploaded. So with that done, it's now time for me to go ahead and set up the InfluxDB. Now, InfluxDB is what is where the data will be stored once collected from the Telegraph. Now, to do that, what I need to do is again run docker run, and this time I just need to go ahead and create the InfluxDB. As you can see, I'm using the InfluxDB 1.8 version. I'm not using the latest 2.0 versions, but rather I'm using 1.8 version. And again, I have set up or deployed this container inside the same network that I created. And I have provided a folder where this container can write to on the host. The reason for providing this folder is because the data can then be saved, so that if the container is stopped and restarted, I don't lose the data that is already present. And as you can see, the default port for 8086 is what I've mounted. So 8086 is mounted to the containers 8086 as well. So on this host, 8086 is now listening to the 8086 port, which is the default InfluxDB port, so that the data that Telegraph collects can be sent to this. And this information is also present inside, inside the configuration file, where I specify that where my InfluxDB is running. So in this case, my InfluxDB is running on the same host, which is 10.0.0.24. This is the host on where my Influx container is running. So I basically say this is the host and this is the port number for it to go ahead and connect. And this is the database name that it needs to go ahead and load the data into. So this information is also provided in the plugin for the Telegraph. With all that information, the influx DB started. It's now time for us to go ahead and deploy the last piece of the puzzle, which is to deploy the Grafana database. Now, to deploy Grafana, I basically follow the same procedure. As you can see here, I am going ahead and running the Grafana service also as a container in the same network. And here I've exposed the port 3001 on my host to the default port 300, which is the Grafana port. And again, I'm just going ahead and providing a folder or a volume on my host where the container can go ahead and write the data. And these are the plugins that I'm going to use for my charts and dashboards. So these are the plugins I'm loading. So once done, I can go ahead now. The IP address of my host, if you look at the IP address of my host, it is 10.0.0.24. I cannot show this just for the security reasons, but you'd have to believe me that the IP address for this host is 10.0.0.24. So with that IP address, I can go ahead and connect to the Grafana at port 3001. So to show that, all I can do is I can quickly open up a portal here, and as you can see, I'm connected to 10.0.00.24.3001. So with that said, I have now set up my my Docker containers. So if I just do a Docker ps -a, you'll see all the three containers up and running. So we are now ready to go ahead and set this up. Now, before we go ahead and set this up, the last part that we need to do is we need to set up Grafana. So if you are aware, or if you've set up Grafana before, you might be aware of exact steps what you need to do. If you've not done that before, no worries, because the steps are very much documented over here on how you can go ahead and set up Grafana. So in this case, you will go ahead and log into the Grafana on this particular as per the information that you have here. So here I will replace this server name or IP address with 10.0.0.24, and 3000 will be 30001, because that's how that is the port on the host to which I've connected. And then I will set up the data source, which means I provide the influx DB location. Again, here it will be 10.0.0.24 and 8086, and then I should be able to load the dashboard. To load the dashboard, I go ahead and import the dashboard first. Again, the script or the YAML file for the importing of the dashboard is already provided in this location, so you can go ahead and load it there. So once you go ahead and do all of that, this is how your Grafana dashboard will look like. So if I just go back to my, let me just cancel. I don't want to save any. So let me just discard. Let me go back here. So once you have added the data, once you've gone ahead and created your data source and imported the dashboard, you can just go ahead and click on the dashboard. You will now be able to see all your information over here. So you can see the different instances that I'm collecting data. So I have an Ubuntu based container which is running. I also am collecting data from a Windows SQL Server running on Windows, SQL Server container which is running on RHEL2 image, SQL Server on Linux. So these are all different SQL servers that I'm able to go ahead and collect the information. So I can see the SQL activities, I can see the CPU queuing and scheduling, wait stats, pretty much all the information that's available on the DMV is available over here. With that, our demo comes to an end, and it's now time for us to go back to the slide.
All right. With that demo, we come to the conclusion for this session. I thank you so much for taking time to attend this session. I hope you liked the content. And in case if you have any questions, please feel free to reach out to me at Amwin87, which is my LinkedIn as well as Twitter social handle. And if you have any feedback for the session, please go ahead and fill the same. And I thank you again for taking time, and see you in next DPS 2022. Take care. Have a good one.